Hello, everyone. This is your very own Sir Thomas, and I welcome you once again to another session of Exploit Tutorial. Exploit Tutorial Learning Made Easy. So, today we'll be analyzing a problem on resolving forces into three components using directional cosines. So when we talk of directional cosines, you see, when we have a 3D system, that's the S, Y, and the Z plane, and a force is being placed in space, we resolve these forces into all the three components, the S component, Y component, and the Z component, to have their vector force. Now, with this particular question, the question says, two forces act on the hook shown. So this is the hook. This is the hook. And the question continues by saying that specify the magnitude of F2 and its coordinate direction angles so that the resultant force Fr acts along the positive y-axis and has a magnitude of 800 Newton. Good. So the question is asking us to find the magnitude of F2. You know, in the question, the F2 wasn't given to us. And again, so we should find its coordinate direction or the directional cosines. So on top of the directional cosines, the directional cosines is the angles. They are the angles a particular force makes with all the angles, all the axes respectively. Sorry. So it makes with all the axes respectively. So realize that when we pick F1, the directional cosine theta y is 60 degrees because F1 makes an angle of 60 with the y axis. So theta y equal to what? 60 degrees for F1. Then we have F1 theta x. So the directional cosine or the coordinate direction for x with respect to F1 is 45 degrees because F1 makes an angle of 45 degrees with the x axis. So we have 45 degrees, and that for the z axis is 120 degrees. Very good. Now, we want to express this F1 or the force 1 in a Cartesian vector form. So F1 bar, which is F1 in a Cartesian vector form, equals the magnitude F1 cos theta xi, cos theta xi, plus the magnitude F1 cos theta yj, plus the magnitude F1 cos theta zk. So all that we are trying to do is that we want to what? We want to represent this magnitude or the F1 in a Cartesian vector form. So if we want to represent the F1 in the x component, it is the magnitude of the force F1, then cos of the angle the F1 makes with the x-axis. The same thing applies to the y component, which is F1 cos the angle the F1 makes with the y, and that with the z component too is F1 cos the angle the F1 makes with the z axis. Please, I hope you are with me. Yes. So follow suit and you will be okay with that. Very good. Now, representing this one in a Cartesian vector form, we give I to x because the unit vector for the x component is what? I. The unit vector for the y-axis is j, and the unit vector for the z-axis is k. So let's take note of that. Now F1 bar equals our F1, which is 300 cos cos our theta x, which is 45 degrees. Then bring our I. Plus 300 cos our theta y, which is 60 degrees. Plus 300 cos our theta. So over here, we put the j for the y, as we did I for x. 300 cos our theta z, which is 120 degrees. Then you add your k. Very good. Now, after solving for 300 cos 45 degrees, we get our F1 bar to be equal to 212.132 I plus 300 cos 45 would cos 60 will give us 150 J plus our 300 cos 120. So over here it will give us a negative 150 K. So the negative and the positive will give us negative. So F1 bar will be equal to 212.132 I plus 150 J minus 150 K. So this is our F1 in a Cartesian vector form. Very good. Now, we have to also represent our F2 in a Cartesian vector form. But here lies the case, our F2, the magnitude of the F2 is not known. And again, so the directional cosines or coordinate directions are not known. So we can't represent our F2 in a Cartesian vector form. But the question says something interesting here. Now, you know that if we have a resultant which is in a Cartesian vector form, in order for us to get the resultant in a Cartesian vector form, it is equal to the F1 bar plus F2 bar. Very good. So we have our resultant in a Cartesian vector form, which is equal to our F1 in a Cartesian vector form and our F2 in a Cartesian vector form, which implies that if we want to calculate for F2, F2 bar will be equal to FR bar minus F1 bar. So this is a simple mathematics. Yes, this is a simple mathematics. Linear equation. So we cross the F1 to the other side to subtract from the resultant force. Very good. Now, we need to find our FR in a Cartesian vector form so that we will subtract our F1 in a vector form from the FR. So FR bar will be equal to, so we need to come back to the question. So the question says that, let's take this part. It says that the resultant force FR acts along the positive y-axis and has a magnitude of 800 Newton. So FR acts on the positive y-axis. That means the x component of the FR is 0 because FR acts only on the y-axis. The y component is 800 Newton J because the FR acts only on the y-axis. So obviously the z-axis will also be equal to 0 K. Please, I hope you are with me. Very good. Now, we need to come back to this our equation that F2 bar equals FR bar minus F1 bar. So we just have to do our subtraction. So please follow suit to get a better and a clear understanding of whatever we are doing here. Yes. So you subtract the F1 from our FR, which is the resultant. So we have F2 bar equal to FR, which is 0I plus 800 J plus 0 K minus the whole of F1 bar, which is 212.132 I